Hello, good evening. This programmer's life back from where we ended in the previous episode. So in the previous episode and every other previous episodes that we have had an interaction in before, we have really talked about quite a lot. Now in the previous episode I started with a question from this section. For those of you who haven't watched, if you're watching this episode and you haven't watched the previous, please try to refer to the previous episode before you come to this one. So I started the previous episode with a question from this section. So like I promised, we shall continuously be revisiting this section so that we can continue to do as many programs as possible. Once again, as a reminder, we said there is no way you can be a programmer, or there is no way you can learn programming without programming. So the first and the most basic way to learn programming is by programming. So as we concluded on the previous episode, I remember I promised you that in the coming episode, which is this one, we are going to be talking about something that is so important and so special. So for this episode, as usual, syntax C++. I want us to look at arrays, then pointers, and references. Wow, this is quite a lot, but of course we are going to handle everything in bits. We have arrays, then we have pointers, then we have references. Now we can use arrays with pointers, we can use arrays with functions, then we can use pointers with arrays, the other way around also. So yeah, a lot we are going to cover in this section, but basically we shall begin from the way they are. So we shall begin with arrays. Now an array consists of a set of objects. Okay, an array consists of a set of objects, and we regard these ones as elements or data items. Okay, all of which are of the same data type, and they are arranged contiguously in the memory. I'm saying these elements or these data items are of the same type, and they are arranged contiguously in the memory. Now in general, only the array itself has a symbolic name. So arrays have symbolic names, okay, by which we refer to them. Actually, these symbolic names can also be known as identifiers, those guys who have been following us from the start. So those symbolic names can also be called identifiers, but it's only the array but not the elements within the array. Now each element in the array is defined by a position. Each element in the array is defined by a position. This position is called an address. Okay, sometimes we call it an index, sometimes we call it which other name do we use? I told you I get most of these things from my head, so I keep remembering as we move along. So I've said each element in the array is defined or is denoted by a position. So this position is known as an index or an address or a bound. Okay, just remembered, or a bound together. Now, the number of elements in an array is known as a dimension. Dimension means number of elements in that array. So from the start we said it's a set of objects. Okay, then an array has a name. Then an array, since it's containing elements, each element is denoted by a position, which we call an address or an index or a bound. Again, an array has what we call a size, and this size is known as a dimension, and this means the number of elements in that particular array. But the size of the array or the dimension is fixed. That is something that is very important to know. It is fixed or it is predetermined, or it's determined, and this means it can't be when the program is in running mode. Okay, so that is something that we need to know by that. So something that we know about an array, yes. For starters, I know it's not yet making sense so much as of now, but at least we have some key points to note out. I've said elements of the same type. Okay, then have symbolic names, which means an array should have a name. Okay, then at the same time each element in the array is denoted by position, which we said an address or an index or a bound. Okay, something to note down here: arrays are vital in almost all programming languages. Okay, so don't make it fixed that arrays are only in C++. So arrays are vital in almost all programming languages. Okay, now here we said a set of objects or elements or data items, and we said of the same data type or type. Now what does this mean? This means that this means that they can either be primitive, or reference types. Okay, so it can be either primitive or reference types, but the concept is items have to be of the same type. Now again, we said arrays have a size, which we said it's called a dimension. Now these dimensions are of two types. We have what we call one dimension, and we have what we call a two dimension, or sometimes we say a multi-dimension. Okay, now one dimension, sometimes this is known as vectors. Two dimension, this is known as matrices, for simple understanding, for those guys who have done some bit of math. Okay, now someone might ask, you're talking about these arrays and you're saying they are vital in all programming languages, but what are the uses of arrays? What are the uses of arrays? One, what arrays can do, they allow presentation. They allow presentation of multiple data items of the same type. Okay, they allow presentation of multiple items of the same type. Then we can say arrays can be used in CPU scheduling. For those guys who have done some operating systems, we have what we call CPU scheduling, whereby processes need a chance to the CPU, so there is what we call a request for use. Now each time a process requests for the use of the CPU, that is in terms of execution, then there has to be a certain protocol which is followed. Now this is done through what we call scheduling algorithms. Now the only way this can be done is when those processes are queued. Now in queuing, it means that we need to implement the concept of arrays, so that is another applicability of arrays. Then one that is also important, used to implement other data structures. Those guys who have done data structures programming. So I can use arrays to implement stacks, I can use arrays to implement heaps, I can use arrays to implement queues, and so many other. I can even use them to implement lists. So that is one of the ways in which arrays can be implemented or used. Now since we know the uses, then we also have what we call advantages of using arrays. Guys, we are trying to understand what arrays are. Okay, we have advantages of using arrays. One, arrays have a better it's called a better cache. Some people call it cache locality. Arrays have a better cache locality, which makes a better improvement in program performance. Okay, that is very, very important. So it's one of the advantages when we are talking about arrays. Then they also allow both random and sequential access of data elements. So we shall see that in our practical environment, whereby if I have data items within the array, I can point to a certain position for a specific item, or I can move through the items of the array sequentially. Now, of course, you can look out for more for that case, but we have also what we call demerits or disadvantages of using arrays. However pretty they may be, however performing they may be, they also still have some challenges. Now, one is that we work with a fixed size. And this means we have a static allocation of memory. So each time we use static allocation of memory, it means that if a program is set in execution, then you cannot modify the size. Okay, now if you cannot modify the size, what does it mean? It means that sometimes you have a problem of insufficient memory. That is the spelling. You have a problem of insufficient memory, or you have a problem of wastage of memory. Insufficiency means what I anticipated to be enough turns out not to be enough as the program is in execution. Then wastage of memory is I anticipated that this will be enough, then I'm working under that fixed size of memory. So it means that certain portion of the memory is going to be wasted. Now, for those guys who have done some bit of data structures and programming, assume we are using stacks. Okay, now stacks implementation using arrays means that at a push operation, we are to face an overflow error. Now at this very point, I'm only talking to those guys who have done some data structures programming, so I'm trying to show you the demerits. So using arrays to implement stacks, at a push operation, we are to face an overflow error. Okay, at a pop operation, I'm just hinting on this, at a pop operation, then we face an underflow error. Okay, at a pop operation, we face an underflow error. So that is one of the challenges that we can face while we are dealing with arrays. So once again, we've talked about a lot about arrays, okay, for now, and there is one thing that we also need to talk about. Okay, we have talked about the applicabilities, we have talked about the dimensions. Of course, we are yet to come back to some of those parts. Now, back again to where we introduced from. Okay, I love saying some things over and over again so that we understand, but of course in different ways. Okay, now about an array having a set of objects or data items of the same data type, then another thing that we need to know is arrays are suitable for representing what we call composite data. Okay, arrays are suitable for representing composite data. Guys, I'm telling you the same thing over and over again, but in different ways for you to understand. Okay, which consists of many similar individual items. For example, this means I can have a list of names of something, so a list of names for people. I can have a table that shows world cities and their temperatures. Have you thought about that? Okay, I have a table that shows world cities and temperatures. Okay, or monthly transactions in a bank about a certain account. Okay, monthly transactions in a bank about a certain account. Guys, I think we are now spanning our brains the more to think about arrays. So as of now, at least we are getting more and more information about arrays. Now, of course, right here we talked about the dimension of arrays. We talked about a 1 dimension, then we talked about a 2 dimension. Okay, so in this point, let's begin with single dimension arrays. Now, single dimension arrays have a single size. Single dimension arrays have a single size. Okay, for example, in terms of a syntax, I'll have a data type, I'll have an identifier, then I'll have a size. By doing so, I have declared a single dimension array. Okay, what do I mean? We can have some examples here. I can say int max. I'm keeping max for 5 students. I can say float prices. I'm keeping prices for 10 items. Okay, I can say double height. I'm keeping height for 3 people. So what am I doing basically? I have declared 3 arrays. This is an array of integers. This is an array of floats. And this is an array of doubles. We said an array can be of any type, either primitive or reference type, but the elements it keeps have to be of the same data type. Okay, and every array should have a name. Now that is what we call declaration. Okay, that is what we call declaration. Now we have what we call declaration and initialization. We have what we call declaration and initialization. Now for us to understand this very well, of course we need a syntax. It will be data type, then identifier, then size, then item can have as many items as possible, then we terminate. What do we mean by that? It means that if I have the same array int max, and I have max, or I'm keeping max for 5 students, one student must have got maybe 56, another one 89, another one 90, another one 45, another one 23, and definitely those are 5 students. Maybe I'm keeping 4 prices of items, and I have 4 items in stock. So one is for $23.0, another one is $89.7, another one is $3.4, and another one is $9.0. Definitely, I think those are 4. 1, 2, 3, 4. Okay, then I have height, which is a double. So these examples for starters can be enough for us. So what I've done is declaration and initialization. It means that you declare the array, at the same time give it items that it's going to keep. Okay, then declaration means that you just identify the data type of the array, you identify the name of the array, then you identify the size of the array. Okay, now assume I had an array of strings. Assume I had an array of strings. Okay, for example, I have an array called days of the week. I have an array called days of the week, and maybe I need only 2 days of the week. So I've declared and initialized. So I have a day called Monday, and I have a day called Thursday. Okay, now I think people can notice the difference. When I'm handling integers, definitely those are whole numbers. When I'm handling floats, definitely those are numbers with floating points, what we call precisions. Then if I'm handling a string, then definitely each of the item inside the array is going to be identified with double quotes. So that is how we identify a string. Okay, so if I have an array of strings, it means that each item in the array is going to be having quotes within. Now when using arrays, we have what we call boundaries of arrays. When using arrays, we have what we call boundaries of arrays. Where is this coming from? If you recall from where we started, we said somewhere that each element in the array is defined by a position, and this position is called an address or an index or a bound. A bound means bound array. Okay, so here we are using arrays. Okay, so arrays are guided by boundaries or indices or positions or addresses. Okay, and the default or the start, it's called start or base or lower bound is 0. That is a must. So it's the default starting point. Okay, so then the limit or the upper bound is array size -1. What do I mean? It means that for this array, which is called max, the starting boundary, the starting index is 0, and the maximum is 5 minus 1, which is 4. For prices, still the starting index is 0, then the end index or the upper or the limit is 4 minus 1, which is 3. Are we clear, guys? So what does it mean? It means that if I'm accessing items in the array, this is what it means. I'll have a syntax. Syntax means array name, then inside we shall have index. By doing that, I'm reading from the array. Okay, how about if I say array name, then inside we have an index, then we have a value. This means I'm writing to the array, because we read from a certain position and we write to a certain position. What do I mean? What I mean is, assume this array which is called max. Okay, I'll comment up here. It means that the item 56 is kept at index 0. No, let me put it here so that it's quite direct. Indices. So this one is at 0, this one is at 1, at 2, at 3, at 4. So when we are using arrays, we begin counting from 0, and 0 means 1. Okay, that is why we said that the maximum limit or the maximum address of an array is the array size -1. That is why 5 minus 1, definitely you're going to get 4. Okay, so let's do it again here. These are indices. We are assuming that this is a memory storage. Okay, how they are stored in memory. So this is 0, this is 1, and this is 2, and this is 3. So it means that 23.0 is stored at index 0, then 3.4 is stored at index 2, and 9.0 is stored at index 3. By default, all arrays begin from 0, and the maximum is size of the array -1. Okay, now what we are going to do, let's borrow this array up here and use it down here for examples. Okay, examples, there we go. So if I wanted to say an example, if I wanted to say out, I got 8 and 9 in programming. 8 and 9 is max into, remember we are using square brackets, max into 2, then I'll say in programming. Is it clear? So if I execute this statement, it's going to say I got 89 in programming. How do I know that it is 89? Because array max index 2 is 89. So what does it mean? It means that each time I want to read from an array or to write to an array, I cannot access the elements of the array directly. So what do? I use what we call indices. And I told you that indices are of two types. We have what we call the base and we have what we call the limit. And I've told you the base is by default is 0 and the limit is array size minus 1. Let's have another example. What if I say out Peter got, I want to say Peter got 45 in programming. That is going to be max into 45 is at index. Sorry, we need to put this one right. This is 0 1. Oh, so that is 1. This is 2. Yeah, so that is fine now. So if I want to say Peter got 45, so 45 is at index what? 45 is at index 3. So Peter got max index 3 in programming. I think that works perfectly well. So we are reading from, this is the syntax, we are reading from. Now writing to, writing to the array. Now we can have an example here. Now what if Peter comes back to the teacher and says I did not get 45. When I counted again, I got 47. So how are you going to change Peter's max? It is very simple. You're going to say max. Peter has 45, that is index 3, and Peter is saying he got 46. He was missing one mark, we assume. So it's gonna be 46. So what have I done? Have changed the value at that index. So what does this one mean again? It means that you cannot have two items in the same position, or you cannot have two data items in the same address. So the moment I say max 3 is assigned 46, it means that I definitely lose 45. Okay, so if I run this statement again, it's going to tell me that Peter got 46, yet earlier Peter had 45. I think it's perfectly understood. So writing to, it means I look for a position and I drop a value. Otherwise, reading from, it means I look for a position, then ask for that value. Okay, maybe more modifications around here, more examples for understanding. Don't forget, we are still under single dimension arrays, how we use them, how we implement them. So what if we had max, and in max I have 2? Okay, let me take 3. What if I had max, and in max I have 2, then plus 4? Okay, then what if I had max, then I have 3 plus 1. Oh, sorry. I have 3 plus 1. Then what if I had max and max is what? Because I'm following the example that we have up there, so it is max. Let me utilize that space. So it is max, then I have 0, and I have a post increment. Question is, if we are to execute those lines of code, what is going to be the output? So if I say index 3, let me break it back down here for easy reference. Okay, there we go. So back again here. So max index 3, definitely that is 45. Okay, hope guys you're understanding. Then we are having max 2, but outside it says plus 4. Now this means that you first focus on the address, which is 2. Now when it comes to 2 I have 90. So then outside the index I'm saying plus 4. So it means that is 90 plus 4, which will make 94. Okay. Now again, we are having 3 plus 1. Remember this is an index value. So 3 plus 1, which makes 4. So we look out for the item which is at index 4, which is 23. Then again on line 118 we are having at index 0, but we are having a post increment. Now at index 0 we have 56. Post increment means that add 1, but add 1 not to the index but to the value at a particular index. So if at index 0 we have 56, then post increment, it means we are going to have 57. Hope that really makes quite a lot of sense. Once again, don't forget, we are still under what we call one-dimension arrays or vector arrays or a single dimension array. Now since we have the details about how to create a single D array, how to access items in the array, how to write to a single D array, then I think we can have an example. But before we have an example, something that is really so important, traversing a single D array. Now traversing means that I'm going to loop through the array, or I'm going to read through the array, but I will print each item in the array. That is what we call traversing. Now the technique is very simple. To traverse through a single D array, we use a for loop. I'll say it again. To traverse through a single D array, we use a for loop. Now of course, I think it was one of the 2 previous episodes we talked about looping, and we talked about the for loop. And I remember telling you that why do we use a for loop? We use a for loop for cases whereby we know the exact number of times that we need to execute a certain code fragment. So that is the same reason as to why when we are traversing a single D array, we use a for loop. Reason being, we know the exact size of the array, so definitely we can know the number of times that we need to move from the very first element of the array to the last element of the array. So we shall use a for loop. Now let's try to have an example. Now the example that we are going to have, we are going to use the one for max here. I think it will make life simple a bit, but of course we are going to have more examples. But before we have those more examples practically that we are talking about, let's have these questions before. We write a program will print all the items in the array below. Okay, which array? Of course, the one that we've just had up here. So let me just paste it there. Definitely, I think that is so doable. To write a simple program that will allow a user to build an array of integers of any size, as required by the user. Then do the following. Let's pause it from there. Write a simple program that will allow a user to build an array of integers of any size as required by the user. Shall end there. Okay, then let's have another one. Write a program for a programming class. Okay, I'm thinking how better we can have this one. Write a program for a class of programmers, that will capture let's be specific, first name and mark for each student in the class. Wow. Write a program for a class of programmers that will capture first name and mark for each student in the class. Okay, then it prints a list of all students along with their marks. Okay, along with their marks. Okay, so I want to make it better. The program should also do the following. The program should also do the following: a compute the average performance of the class. Okay, B saying compute the average performance of the class. What else can we have? Return the best performer in the class. Number 4, Guys, I'm brainstorming questions here just to help us understand single dimension array. Number 2 was write a simple program that will allow a user to build an array of integers of any size as required by the user. Let's make it clear, then print the array. Okay, now number 4 is modify the program so that it can print the original and the reversed array. Then it should count the number of events in the array and the number of odds in the array. Wow, so guys, we end this session with these programs about arrays. For any questions, please reach out to me, +256 751 8249 73. Subscribe to my YouTube channel, Programmer's Life. I sign out.